In this video, I'm going to introduce to you nth root functions. So, before we do that, I want to talk about what the difference is between these two statements. So the difference is, what is the square root of 25 and then the radical 25? And we've spoken about this, and we spoke about what does this symbol mean, and we have said that it is the principal square root. So the square, if you were to say, what is the square root of 25? Meaning, what number when you square it gives you 25? The answer is technically 5 and -5, right? There are two numbers when you square it gives you 25. However, when we say the square root of 25 with the radical, this is called the principal square root. And therefore, if you were to put this into a calculator, you would get just 5. So it's important that the radical, when you understand the square root, when you say just the radical, it is just the square root of 25, the positive, which is 5. Now, let's talk about radicals. So here's some vocabulary for you. This symbol we know is called the radical sign. That is the first word. That is not new, but it's a vocabulary word. Also not new, this right here, the number or variables or anything inside of a radical is called the radicand. And lastly, this is a new word. This number right here, the n, is called the index. Okay? Meaning, what root are you taking? So we're studying nth root, right? Nth root, meaning n is going to have a number. So it could be the second root, but we don't call it the second root. We call it the square root. Third root would be cube root, right? So we've seen cube root of something. We've seen the fourth root of something. When there's square root, what is the invisible index that's here? Well, if this is cube root, what do you think square root would be? There is an invisible index of 2. So it is the implied number. If the number is not there, it is implied to be a 2. Okay, so that's some words that we need to know. We have index, radical, radicand. And let's look at what that would look like. Well, and let's be clear. This is the principal root, meaning it holds the sign. And let's talk about what that means. So if we have the cube root of 27. So the question is, what cubed is 27? And this is pretty simple. We've done things like this. What number cubed gives you 27? Well, the number is 3. So the answer here would be 3, because 3 cubed is 27. Okay, well, what about the fourth root of 16? So what to the fourth power gives you 16? The answer is 2. So the answer here is going to be 2. The fifth root of 32. So what to the fifth power equals 32? The answer is, again, 2. So we would get 2. Square roots don't show an index number, but they are still second roots. That we said before. It's implied. Okay? So that's pretty basic stuff. But what happens when there's a negative inside? Well, we're going to set it up the same way. This is squared, right? What squared equals -16? Again, we're in the real number realm. -16. Nothing. I can't really put an X there because that actually means something in math. So we'll put this. Nothing. So this is not real. Not real, you'll put. Okay, what about the next one? The cube root of -27. Something cubed equals -27. Does this exist? Well, here's the thing. Cubes hold their sign, right? If I cube negative 3 times negative 3 times negative 3, this becomes positive 9 times negative 3, which is negative 27. It is not like squares where every answer is going to be positive. Here, it is negative 3. So the cube root of negative 27 is negative 3. It holds the sign. Okay, fourth root of negative 16. It is even, meaning it is not going to hold the sign, meaning it is not real. And the fifth root, something to the fifth power, is negative 32. Well, it's going to be similar to the fifth root of 32, but it's going to be negative. So this is negative 2. So it holds the sign. When it is odd. When it is odd, it holds the sign. When it is even, it's either positive or not real. So this is odd roots versus even roots. Odd versus even. The index, whether it's odd or even, matters. And now we're going to talk about simplifying nth root expressions. Okay? So it's not anything crazy. We're not doing anything super, super crazy. We're just going to do 2 problems. So when we have the square root of 25x to the 4th, this is the same thing as me saying the square root of 25 times the square root of x to the 4th. Well, the square root of 25 is super easy, right? Square root of 25 is just 5. What about the square root of x to the 4th? The question is, what squared gives me x to the 4th? The answer is x squared, because 2 times 2 is 4. So this would be x squared. So your final answer would be, where am I going to write this? 5x squared. What about the next one? You have 36, a to the 6th, b to the 12th. It's going to get longer as you go on. It doesn't make it more difficult. It just, you have to do it piece by piece, especially these are all perfect squares. So it's super simple. So we have 36. The square root of 36 is 6. The square root of a to the 6th. So what squared gives me a to the 6th? The answer is a to the 3rd, because 3 times 2, remember our exponent properties. When you multiply, when you do a power to a power, you multiply. So this is going to be a to the 3rd. And lastly, b to the 12th, which is a great vitamin. You should really take it. Squared is b to the 12th. What's going to be? It's going to be a to the 6th. So notice how you're really just dividing this by this, whatever your index is. So you're going to get a to the 6th. So your final answer would be 6a cubed, b to the 6th. But here's something that you guys need to know. You see this little statement on the bottom? It says, you need to use absolute value bars if the power goes from even to odd. So I'm going to take a step back real quick. And if you notice here, our power went from even to odd, right? 6 is our exponent to 3. And when this happens, you have to use absolute value bars. Why? So I'm going to put absolute value of a cubed. Why does this happen? Because a to the 6th, if we look at a to the 6th, a to the 6th will always, always, always be positive. right? So no matter what the A value is, if it's positive or negative, it is always going to be positive. The problem is that A to the third will not always be positive. So these are technically, these right here can't be equal, because if A equals, let's say, -2, so let's say A were to equal -2, A equals -2, you would get -2 to the 6th squared, which is 64, right? -2 to the 6th is the square root of 64, which then becomes 8. Here's the problem. What is, in theory, these should be equal. -2 cubed is not +8, it is -8, and these are not the same. So you have to, when it goes from even to odd, you have to put absolute value bars here, so that the absolute value of it is going to be the same, which it is. So, in recap, when you go from an even degree to an odd degree, not the other way around doesn't matter. When you go from an even degree to an odd degree, you have to use absolute value bars. And so you would get 6 times the absolute value of A cubed times A to the 6th, which, the way that we set it up, we always put whatever's in the absolute value at the end. So you can say, oh, this is supposed to be a B. Yikes. This is supposed to be a B. This is supposed to be a B. And this is supposed to be a B. And so you get 6B to the 6th, A, absolute value of A cubed. That is your final answer. Even to odd, absolute value. We're going to do one more problem. So if you have something like this, if you have a coefficient, which the coefficient here is what? Coefficient here is -1. If you have a coefficient, doesn't matter. Just stays on the end. But what is the cube root of 8? You do every single thing one by one. Numbers are included here. So the cube root of 8 is 2. The cube root of A to the 12th power, 12 divided by 3 is going to be A to the 4th, because A to the 4th cubed is A to the 12th. And let's see if I actually write the right letter. B to the 15th, cube root of that is B to the 5th. Because B to the 5th, we cube that, you get B to the 15th. Do I have to put any absolute value bars? The question is, did any of them go from even to odd power? No. So, no absolute value bars. This just comes down, just going along for the ride. So my final answer is -2, A to the 4th, B to the 5th. And you're done. The last point I want to make before I finish this video off is, when you have something that looks like this, this is a unit. It goes as a unit. You do not separate the unit. So for something like this, you would do 64 first. You'd get the square root of 64 is 8. And then this whole thing, you take the square root of it to the 6th. And again, it's a unit, so it's x plus 3 to the 3rd. 6 divided by 2. Remember, that's your index. And then the plus or minus comes along for the ride, just like anything else would. So the answer would be x plus 3. But what do we need to put here? You have to put absolute value bars, because you went from an even degree to an odd degree. So this really is the absolute value of this. And now you're done. That is all. Have a great day. Bye.